Looking at the questions, so the problem we've got this time is to find the equation of the point which moves so its distance from the point 03 is equal to its distance from the line. So there's the key. So we've got a point 03 and we've drawn it up here. If you're not sure about something, draw it up, get an idea of what it looks like. So there's our 03, that's going to be our focus. We've got the line down here which is y is equal to minus 3. And the point that moves is equidistant, so the distance there is going to be the same. So if we play around with this a little bit, this is the point xy. That's point xy. The distance there is y. The distance here is 3 because it goes from 0 down to minus 3. So the distance there must be 3. That's y. There's our distance there of y plus 3. So the distance over here of y plus 3 is there. So this part here comes from the focus, which is 03, and the point P, which is xy, and we've applied the distance formula. Now to clean it up, what we need to do is get rid of the square root by squaring both sides. So that's why it becomes y plus 3 all squared. X squared then is going to add to the y minus 3 all squared. Expand that out. So x squared plus y squared minus 6y plus 9. Expanding this side, we get the y squared plus 6y plus 9. So we expand our terms correctly. We can cancel terms because y squared will subtract from y squared. 9 subtracts from 9 there. We add 6y on this side, and we get x squared is equal to 12y. So it's back in that form of x is equal to 4ay. 4ay. And we can see that if you got 12 there, 4a would equal 12, which means that a is equal to 3, so our focal length is 3, which makes sense because its distance focused to the vertex there, as it would be 3, and it's 3 units down to the directrix. So in this problem here, write down the coordinates of the parabola with a vertex at the origin. So you know your vertex is at the origin, and your focus has the coordinates of 0, 2. Well, if we know our equation is going to be in the form of x squared equals 4ay, because we're told it's a parabola, so we can start with that premise. What we need to do, we know x and y are going to be variables. A is the only one that's going to be fixed, and a is the focal length. So that's what it requires us to do. If our focus is at the origin, our vertex at the origin, our focus is at 0, 2, our distance from the origin to the point 0, 2 is 2 units. So that must be our focal length. All we need to do is sub it into that formula. 4 times 2 times y gives us the equation x squared is equal to 8y. In this question, we've got to again write down the equation of the parabola. So we're told it's a parabola already, we don't have to prove it. Vertex this time is at the origin again, and the directrix is having an equation y is equal to 5. This one's a little bit different. The directrix this time is above the vertex, not below it, which means our parabola must be concave down. So there's our first key. Vertex is at the origin, directrix is above the x-axis, which so it's got to be concave down. It's got to be going this direction because the focus must be below the x-axis in this case. So concave down, which means it's going to be negative. So it's going to be the form of x squared is equal to negative 4ay in this case. So x squared is equal to negative 4. We've got to find a. A is equal to 5 comes from the fact that the distance between the directrix and the vertex is going to be a focal length as well. So we know that's a distance of 5 units there. So that's where a comes from. We substitute that in, gives us minus 20y. Again, a negative there would indicate that it's concave down. X squared is equal to minus 20y is the equation of a parabola that's concave down. So you've got to be careful about that situation. In the next question here, we've got to write down the equation of the parabola with the vertex at the origin. Latus rectum is the length of 5 units. Now, you can prove that the length of the latus rectum is 4a. You can prove it, but as long as you can know that the length of the latus rectum is 4a, again, it allows you to find the focal length. And that's the key. If we're going to use the equation x squared is equal to 4ay, we need to find a every time, which means that a is going to be our focal length. So 4a is going to be equal to 5 because the length is 5 units, which means a is equal to 5 over 4. And x squared then would equal 4 times 5 over 4 times y, which is going to leave us with x squared is equal to 5y, because the 4's will cancel. Now, what do we got to consider? It doesn't say whether the length of the lattice rectum is above the x-axis or the length of the lattice rectum is below the x-axis, which means we could have two different parabolas in this case. So if it's above the x-axis, it would be x squared is equal to 5y. Basically, we're going to get a congruent parabola because it's going to be concave down, because you can have a lattice rectum that would be going through the focal length and going to be in the same distance, So we get x squared is equal to minus 5y.